Today's goal is to evaluate the sine, cosine, and tangent of key reference angles in the unit circle. Most functions we worked with this year so far take in one number and spit out a different number. So, for example, the function f of x equals 2x plus 3 has the relationship f of 1 is 2 times 1 plus 3 is 5. It's taking in a number as its input or x value. It's spitting out a different, perhaps different number as its output or y value. And f of negative 2.3 is 0.4. The input is a number, the output is a different number. Similarly, the function g of x equals 100 to the x takes in numbers and spits out some numbers. We know that g of 0 is 100 to the 0 power, which is 1. Or g of 1/2 is 100 to the 1/2 power, which is the same thing as the square root of 100, which is 10. It's taking in numbers, it's spitting out a different number. Likewise, g of negative 2 is 100 to the negative 2 power. That's 1 over 100 squared, which is 1 over 10,000. It's taking in numbers and spitting out different numbers. But not all functions just take numbers and match them up to other numbers. For example, the Coke machine, right? You take a Coke machine, you put in your money, that's your input or your x value, and it spits out a can of pop, that's your output, right? The input is a different type of item, money is different than a can of pop. Or, for example, price of cookies at a bake sale. Maybe the price depends on how many cookies you buy. And so the input, like whatever this is, maybe you buy one cookie for 50 cents and you buy 3 cookies for $1. The input is a number of cookies, the output is a number of dollars. These are different unit measures. So there are 6 trigonometric functions. This word trigonometric, which should be sine, cosine, and tangent, are all examples of trig functions, or more formally trigonometric. The key of the root of this word is trigono, which is Greek for triangle. So trig functions deal with triangles, and today we're only dealing with 3 of the 6 functions. Tomorrow we'll look at the other 3. And trig functions don't just take in any number and spit out any other kind of number. They take in an angle measure, and they spit out, this would be like your x and your y, and trig functions always take in an angle measure, and they spit out a ratio of side lengths. Just like a Coke machine, the type of number you're putting into the function is different from the type of number or the type of object you get out of the function. So I like to use the phrase SOHCAHTOA to help me remember how to evaluate the sine, cosine, and tangent of an angle. You'll have to memorize how to spell this correctly because the spelling is the key, SOHCAHTOA. Let me show you what I mean. If we're given some angle A and some triangle, okay, SOHCAHTOA tells us that the sine of the angle A, abbreviated SIN, the sine of the angle is the ratio of the opposite to hypotenuse of the angle. Now the side across from it, that's the opposite. So in this case, 20 is opposite from A. And the hypotenuse, that's the longest side. That's the side across from the right angle. So the sine of A is simply 20 over 29. That's it. You're taking in an angle measure and you're spitting out a ratio or a fraction of side lengths. The cosine of A, well, I gotta spell this out. SOHCAHTOA. Cosine of A is the ratio of the adjacent side length to the hypotenuse. Adjacent simply means next to. So, of course, A is next to the side length 29 and the side length 21, but 29 is the hypotenuse since it's the longest side and the side across from the right angle. So we say 21 is the side that's adjacent to A, and 29 is the hypotenuse. So this ratio or fraction is the cosine of A. Input is an angle, output is a ratio of how long those sides are. And the tangent of A, you've probably guessed, is the ratio of the opposite to adjacent side lengths. So that's simply, in this case, 20 over 21. Now let's take a look at some angles that are in the unit circle. That's our real aim, is some key angles for us. So if we want to evaluate the sine, cosine, and tangent of pi over 6, well, you know how to draw the angle pi over 6. It's closer to the x-axis. And you know how to label its coordinate pair, so this would be root 3 over 2, 1/2. But this feels different from example 1 in that there's not a triangle drawn. So let's take a look at a more general case first, and we'll come back to the pi over 6. If we're looking at some angle, doesn't really matter what it is, and it has a coordinate pair x, y, that's because you traveled x length to the right to get there, and you traveled y distance up to get to this coordinate point. So this angle produces a reference triangle, the triangle I've just drawn, with side lengths x and y. So here's my angle, we'll just call it theta. So generally speaking, this is general because I'm not giving you numbers for x and y, but generally speaking, we know we can apply SOHCAHTOA to this triangle since it's a right triangle. So we can see that the sine of theta is equal to y over the hypotenuse. Well, if this is in the unit circle, the hypotenuse is 1, and y over 1 is just y. So the sine of theta is its y value of the coordinate pair, if it's in the unit circle. The cosine of theta would be adjacent, that would be x in this case, over hypotenuse, that would be 1, and x over 1 is just x. So if an angle is in a unit circle, its cosine value is the x value of its coordinate pair. And then the tangent of theta is opposite over adjacent, which would be y over x. And I notice that's sine over cosine of theta. So these are really, really, really critical formulas you're going to need to memorize. Let me show you how you can apply them. Here's our angle pi over 6. We know its coordinate pair is root 3 over 2, 1/2. And so if we want to find the sine of pi over 6, that's just its y value, 1/2. And the cosine of pi over 6 is simply its x value, root 3 over 2. Then the tangent of pi over 6 is its sine value, 1/2, over its cosine value, root 3 over 2. And we know that dividing fractions is the same thing as multiplying by their reciprocal. You get 1 over root 3. We don't want to leave it with a square root in the denominator, so it's just root 3 over 3. Okay, so let's take a look at 3 pi over 4. Well, that's in the second quadrant, halfway between the axes. So its coordinate pair is negative root 2 over 2, positive root 2 over 2. So the sine of 3 pi over 4 is just its y value. And the cosine of 3 pi over 4 is simply its x value. And the tangent of 3 pi over 4 is sine over cosine. We can divide by multiplying by the reciprocal. This cancels. We're left with just negative 1. Okay, let's take a look at 3 pi over 2. This is our last one today. 3 pi over 2 would land us here. And it's inside the unit circle, which of course has a radius 1, so its coordinate pair is 0, negative 1. So the sine of 3 pi over 2 is its y value. The cosine of 3 pi over 2 is its x value. And the tangent of 3 pi over 2 is sine over cosine. We know we can't divide by 0, so the tangent of 3 pi over 2 is undefined. That's it.